Hello everyone, I am Pawan Dheeraj. Our project is deep learning based shrimp disease detection for Aqua Farmers. This project is guided by our professor Kanagajidambranathan sir. Our teammates are Suraj Kumar and Nagarjuna. Abstract. In this project, we are concentrating on aqua farmers who are doing shrimp cultivation. As shrimp cultivation plays a huge role in India's GDP, when we want, like India is exporting a huge amount of shrimps to other countries. In particular, year 2016 to 17, India benefited like around 37,871 crores been added, got India through this shrimp farming. As India is a peninsular land, throughout the coastal regions of India, shrimp cultivation has been done. In shrimp farming, particularly, we'll be concentrating on Vanami shrimps, as these are the special kind of streams has been exported throughout the world. While doing there are so many challenges faced by farmers while doing vanilla stream cultivation, when they are cultivating. If they want to cultivate, they have to invest more amounts, like in crores, like around 4 to 5 crores they have to spend on farming, vanilla small, those cultivations equipment and all. Even after doing all these things, there should be 24 by 7, people have to observe these streams, because these streams can be attacked due to, these are vulnerable to many kinds of viruses. If these streams got infected, even people can't identify these diseases because of lack of knowledge. Most of the farmers are getting losses, and it's a drawback to India's GDP also. So we are focusing on sorting out this problem. Our proposal is like in our project we'll be developing a mobile application interface, usable by farmers. So farmers will be installing the application, and they'll be taking the photos of streams, and they will be sending these photos to our knowledge base server. In that knowledge base server, we'll be giving training to our model will be there, and we'll be giving training to that model, like whether the given input photo contains image stream has any disease, like it's a white spot disease, red spot disease, mud gut disease, or is it a normal stream. It will identify, and it will send these data to the knowledge base, and this knowledge base analyzes whether it has any disease. And if it has any diseases, it will send farmer as a in form of feedback, your streams has been infected with these kinds of diseases. So these are the precautions to be taken to reduce the further spread throughout the pond. You have to use these kind of chemicals. You have to reduce the food supply to the streams. You have to take care of isolating the pond from other ponds, and it will suggest some other healthy tips to the farmer. So in that way, he can get out, somehow he can get out of the risk. It helps farmers. Objective. Aim of a project is to develop an application which allow farmers to analyze whether their streams got infected. And even if stream doesn't got any infection, it also says that your stream is healthy, and follow these kinds of measurements to have a healthy growth to your streams and get more amount of profits. A complete analysis of the record of stream will be provided to farmers to create awareness about stream disease and the prevention and control methods to avoid any further infection. Scope of our project is, we'll be suggesting farmers with the prevention and control methods to avoid the further infection spread. It's like a kind of awareness, who are not aware of different kinds of diseases gone through the Vanami streams. So they will be helpful. This is the introduction part. Literature review. We have concentrated totally on five literature papers. In first paper, this study investigates about the particular kind of disease, whether it's present in management parameters and water quality, and consequently invested Vanami streams settled in public coastal area. So it's whether in normal area, what are the physical parameters which causes the infection. It's all about the first literature review. And in second literature review, aquaculture reports. They are used as a biometric model to understand and analyze the impact of the acute hepatic necrotic disease of Vanami streams. This is uh, this is the most popular disease. This is one of the most popular disease which creates a huge problem to the economical conditions of the aqua farming exportation. So the second paper concentrates on only one particular disease, and third one is about microbiology. The disease will be undergone through microbiology level, whether how disease from each and every country, it analyzes which country is affected with what kind of disease, mostly like that it's all about. And remaining are also similar type, like socio-economic challenges to address them, and what are the approaches to be followed to further studies to implement these techniques. And the review is fifth literature review is about increasing proof has emerged a good link among the microbiology and host organic process stages. It's like what kind of organic food do we have to give to shrimps to improve their health conditions. Design and methodologies. We have split our model into three modules. In first module, we'll be collecting the venomous shrimp disease data and we'll be training our model using deep learning algorithms. In second module, we'll measure the accuracy of a model and we'll do some modifications if any required to increase the accuracy of a model. In third module, we'll be directly giving the real-time data from the farmers. We'll be collecting data from the farmers. Directly, they will be giving the live stream photo and we'll be identifying whether it is got infected or not. Implementation. We have implemented our project in five diagrams, like architecture diagram. In this architecture diagram, if you see, healthy shrimps, infected shrimps, brown spot disease, this is a white spot disease. So different kinds will be for giving is knowledge base 1, knowledge base 2, knowledge base 3. In first knowledge base, we will be giving healthy shrimp photos. In second one, we will be giving a white spot disease, one kind of disease, and second brown spot disease, it's also another kind of disease. And we will be giving these inputs to our model that uses conventional neural network. It has about 16 layers, in which first layer contains, due to complexity I have shown only 4. It's like around 14 in deep layers are there. One is input layer and one is output layer. So this data will be sent to the knowledge base, and by using in-situ sensor data like how the temperature of the pond, dissolved oxygen content, pH level, and water temperature, atmospheric pressure. These kinds of data will be also sent to the database to lively, so they can analyze whether stream got any infected. So on what kind of parameters those streams got this disease, we can easily identify through this architecture diagram. So this is how farmers is using our application mobile interface. Data flow diagram, collection of data, pre-processing of data, create a perfect data, apply deep learning algorithm, learning the data, testing the data. Diagram. In our data, these are the entities like disease name, symptoms, cause, prevention methods, images, model, code. These both will be at initial level, we'll be implementing it through using a Raspberry Pi. In that, we'll be using Jetson Nano chipset, where our code runs using Linux, Ubuntu, Linux distribution, Ubuntu 20 point LTS 20.0 point version. By using that, we'll be executing the code. In future implements, we'll be implementing this entire code implementation in cloud servers. Use case diagram, sequence diagram, CNN architecture of the proposed module, hardware specifications we used, like CPU, RAM, storage, and Jetson Nano chipset. It's like a basic introduction. What is the use of it and what is the purpose we are using it. Software requirements, we will be using our code editor as PyCharm IDE, and Ubuntu LTE 20.04 is used for the command and interface. These are the input and output screenshots. These are the screenshots. See, if you see, this is the data we have given to this. After executing, it shows like the disease given is white spot disease, like 0.393. It's like a 93% it verifies the given photo is a white spot disease, and 0.029, it's like 0.02%, 2%. It may be a fungal, it may be a virus like 1 point, it may be a bacterial like 1 point, brown spot, etc. So it identifies accurately like a white spot disease, like 93% accuracy. This is the graph we have been using. We improve the accuracy by using 10 photos, 50 different photos, and 100 photos, based upon the time limit, based upon the number of images, time taken to run the algorithm, run the code, data set code. This is the output screen. In this output screen, I'll show you the execution, but it is a white spot disease. It is a normal stream. Conclusion. So we conclude our project like an efficient framework to identify whether stream got infected or not. In that particularly, we have got 93% accuracy for identifying white spot disease. The system is designed to real-time processing and with the cloud-based environment validated. These are the conclusions and future enhancements. In future, if we implement it in real time, then it will be helpful for farmers to reduce their high investment risks, which ruin their entire investments due to the technology enhancements of cloud computing and machine learning image classification. This can be made possible, and also we'll be adding like live sensor data into the sensors. Will like it will be used to collect the live data, live physical parameters of the pond, like pH value of the water, atmospheric pressure, water temperature, dissolved oxygen, etc., etc. Things. This is our poster presentation. I'll show you. Plagiarism. We have found out 8% plagiarism report. Video references. References. These are the references we have used. And now let's go to the execution part. Execution part. Just a minute. See, now I'm showing you the execution part. Sudo cs. This is the folder I'm working on. If you want, I think you are able to see this. See, now at now right now we are gone into the desktop. White spot, that is the location where the code present there. I'm showing you the in that particular folder what are the kinds of files we have stored. Like, see, in this particular folder we are carrying white spot disease photos. This is a stream infected with white spot diseases. So these images, we have collected vast amount of large amount of images of this disease, and this data, these images will be sent to the module called execution.py, prediction.py. This is a file we are using. Python 3 is the command we'll be using, and predict.py, this is the model where our code stands, and we are giving the input as a white spot disease image we are giving. So at this particular point, we are on the particular location. We are using python 3 command. We are using the code execution file, and this is the white spot image data we are giving it to that. After giving the white spot image, we'll be getting the output. See, let's wait for the output. Just a minute. It's loading. Just a minute. Based upon the number of images, it takes some time. So it is a white spot disease. So we have given to our code, we have given the input is white spot photo. So after the execution, it identifies it as it is a white spot disease. So the stream got infected with the white spot disease. Now I'm giving you the demo of the normal stream disease also, normal streams also. Now we are going to the other folder. In this folder we have photos of a normal stream. So this is a healthy stream without any infection. Now we are giving this photo as the input to our Python code. So we have cleared. Now I'm going to the particular folder. Now I'm giving you the execution command line python 3 prediction.py. This is the code code execution code present, and we are giving the input as a normal photo, normal stream photo. After execution using TensorFlow backend. Just a minute. Just a minute. It is a normal stream. It is a normal stream. So that's it. That's how our algorithm works.